evening, depending on where you may be. Thank you for standing by and welcome to today's Tivoli User Community Webcast. Our topic for today is Establish a Predictive Maintenance Culture. Complement Maximo with predictive analytics to increase asset reliability. All phone lines are currently in a listen-only mode, and later there will be a question and answer session with further instructions being given at that time. You may ask a question at any time during the presentation using the chat window located in the control panel. Questions will be answered at the end of the presentation with the rest of the Q&A. Today's session is being recorded, and you'll be provided a copy of today's materials following the call. Now I'd like to introduce our speaker for today. Dan Biggis is the Industry Marketing Manager for software solutions that support asset performance management and optimize throughput, improve quality, and minimize risk in asset-intensive industries. Dan has 10 years experience in IT management and 20 years experience in the line of business software solutions. Dan, take it away.
Great. Thanks very much, Sam, and thanks to everybody who's spending the time with us today. Over the next couple of minutes, I wanted to give you a sense of the complementary capabilities of predictive analytics and the investments you may have already made in Maximo. The overall theme of this is that the combination of these two products, the two capabilities, they can really help improve your overall maintenance practices. Some of the things that we're going to discuss today and just kind of set some standards and ideas for thought. Things about your current maintenance strategy, identification of critical assets, trying to establish a sense of how well instrumented your assets are, your ability to capture some of that performance or operational data, questions about the types and the volumes of data that might be associated with those particular assets. For some of you, we realize you already have digital inspection and repair records, and that can be significantly beneficial in applying predictive analytics to gain some insight from that information. And then the importance of things like the right analytical tools and skills within the organization to really help get the value from the operational and performance data. And then we'll poll you on what you think might be some significant management challenges as you kind of advance your maintenance strategies and practices. What's really interesting is the number of people that have registered for this and the diversity of industries that are represented. So I included that at the bottom of this particular slide.
Hey, Dan, I'm sorry to interrupt you. I don't think the slides are advancing here.
They're
not.
Still
on the title slide.
How about
now?
There
we go.
Okay. Okay, yeah, so I just iterated some of the topics and areas that we'll cover in this particular webinar. When we think about a continuum of maintenance practices, we've kind of established this, and a lot of you already are familiar with this, depending upon the industry or the type of assets you have responsibility for. In many instances, the reactive maintenance or let that machine run to failure might be appropriate. Many of you have already adopted the preventative maintenance or the condition-based maintenance, and we really want to focus on the applicability of predictive maintenance to complement what you might already have in place. With the idea of predictive maintenance, it is using the information from historical operations and data from those assets, building predictive models to help you get a much better idea of the asset health and impending failures. If we look at this on this particular slide, you're familiar with the PF curve. What we want to do with predictive maintenance is really look at those sources of data from your critical assets, do an analysis of that, so that rather than having something, a machine alarm or some physical indicator or something that shows up when you're doing a PM, really get into that predictive mode. So when there are minute changes in underlying operational characteristics, you can identify those as early as possible with the idea of being very proactive and addressing those. And the obvious implications there are reducing the overall maintenance costs, greater asset availability and reliability. We will be primarily focusing on that aspect of predictive maintenance in this session today. There's another aspect too, and that is predictive quality. And really for those of you that are in a production manufacturing mode, applying predictive analytics to the actual processes of manufacturing, looking at the quality of the components or quality of the processes, taking readings from those, and when we see that there's a particular deviation from a norm or a particular standard, using predictive analytics to alert that information, will alert you much earlier than traditional statistical process control methods might be. What we found in applying the IBM quality capabilities is that we can actually identify those potential problems sometimes hours, days, and even weeks earlier than statistical process control methods. We've got a polling question we'd like to begin with, and that is, we're doing several polling questions in this session, and part of that is really for your benefit, and get a sense of where you think your particular organization is operating, as well as get a sense of where others in your particular industries or particular lines of business might be operating. So Sam, if you want to launch that polling question, we'll do that.
Yeah, sure. We just launched it now, ladies and gentlemen, so please feel free to weigh in with your answers here. We'll give it about 30-45 seconds to let everyone get a chance to let us know their thoughts.
And note this is some multiple answers. We realize that there's not one particular characteristic that classifies a particular maintenance strategy in an organization. But our sense here is how would you, for this particular community that's assembled here, what are the overall trends and how would they classify their particular practices?
So we'll give it another 5-10 seconds here. Let everyone else get their votes in. All right. So, in terms of how would you classify your current asset maintenance strategy, 37% answered reactive, 60% are preventative, 35% are condition-based, 21% predictive, and 9% are other.
We realize that adds up to well more than 100%, but a kind of general sense here that the majority are indicating preventative is the primary practice, with an equal number in reactive and condition-based, and 21% being predictive. I think when we get to the Q&A session, for those of you that have already implemented predictive capabilities, I might be interested in hearing your perspectives regarding that. Let's go back to the close this poll. Okay. In this particular slide, this is really the big picture of what we're doing with predictive analytics, predictive maintenance. And think about that motor in the upper left-hand side as your critical asset. And the capabilities that are required in order to apply the predictive analytics are really along these lines: identifying those critical assets, having instrumentation already part of that asset, or applying that if it's an older asset, and then gathering the historical operational data from those assets. So that could be something, whether it's SCADA data, whether it's from the historian. But we also look at maintenance data. So if you are digitally capturing maintenance records and such, we can actually use that and apply that information in developing the overall predictive model. For organizations that are widely distributed, things like Wi-Fi and connectivity become very important in contrast to having a hard line or a hard wire connectivity to the particular asset. Then the most important part of this is actually applying the analytical capability to take all of that operational historical data and apply predictive models that best describe the performance of that particular asset, with the goal of identifying key sources of data, key data that really predict the potential failure or degradation of that asset. Once that particular analytical model is in place, we then apply that in real time to monitor that asset as data is coming in, comparing that against historical trends and predictive model, and then giving some real-time assessment of the overall health of that asset, as well as any predicted potential degradation or failure. Plus the ability to do quite a bit of reporting over that asset, whether it's historical information, monitoring the overall maintenance schedule. So we'll go into much greater detail in a little bit. But think about that information across the top, whether it's those visuals across the top, and think about how that might apply to your particular industry, your particular critical assets, and then applying these capabilities, delivering that dashboard example as we have in the middle of the screen, with the overall benefit outlined at the very bottom of the screen in terms of unplanned downtime reduction, reducing maintenance costs, extended asset life, etc. I think many of you are very familiar with potential capabilities and benefits thereof. We're going to take that same concept we just talked about and go into much greater detail in terms of the modeling and the actual application of that model. So those gears represent your critical assets. And in the modeling process, we're looking at things like unstructured information, maintenance logs, repair invoices, warranty claims. And these all would necessarily have to be in a digital format so that we can do the analysis of that. We'll also look at the sources of performance or operational data that are generated by that asset. And using a combination of that information, we'll bring that in, acquire that information, consolidate that, and then use our analytical capabilities and tools to develop the specific analytical or predictive models that are relevant to that asset. And we develop that particular model, and then we'll be using that model in real time, applying that to the real-time operational data that's coming from that particular asset with the idea of assessing the asset health, the overall asset score, health score going forward, and ideally identifying any potential problems or asset degradation very early on. But we also do something significant beyond that predictive model, and that is the idea of optimizing your decisions. And that is when we do sense that there's a potential problem with a model, with a particular asset, what are the recommendations to be taken? And that is based upon looking at the analysis of the historical maintenance records, identifying maybe what the top failure factors are. And so we actually give you the capabilities and rules to actually determine what particular procedures or what steps should be taken when you have certain asset conditions. And the idea behind this is, rather than just alerting you to the potential problem, use that historical information, use analytics to provide kind of the best action, the next best action that might be taken. So once we have that model developed, then we're going to focus on actually looking at that real-time data that's created by the asset. In this particular diagram, the red box around that, the performance of the operational data, we're reading that in real time, and we're comparing that against our predictive model and the asset performance portion of this particular screen. If there's a potential or there's an alert as part of that, if we're experiencing predicted asset degradation or potential problem, there you get into the ability to act upon that. And that's what we'll talk about the integration with Maximo in just a little bit. But the ability to automatically initiate a work order or to look at your particular maintenance or production schedule and make modifications accordingly, potentially conduct root cause analysis if it's a relatively new process that you have in place. Or if you happen to be an organization that really is in the doing service so that your products are out there used in the field by your clients, this could act, and you're monitoring those, this could potentially initiate a service call or help you give a better understanding of particular asset usage and potentially modify your service or warranty programs. At the very bottom of the screen, if we're focusing on the quality aspects of that, when there's an alert because there's a drift in the overall quality measurements on the process or particular production sub-process, we're going to alert you to that, initiate particular investigations such as, is this an issue of raw materials or components that I'm working with? Should I modify upon a particular process design, or do I need to make a change in the actual overall product? So the overall focus here is primarily on, at least for our conversation, the asset performance and developing those predictive models and then applying those in real time to get a better understanding of the asset itself. Polling question number 2, and we realize that depending on the industry we're in, this varies, and that is, how well instrumented are your critical assets today? Not at all, very little, almost all, completely. This is an important factor because for those of you in organizations or industries that, in which you've had assets in place for 10 or 20 years, this becomes an important part of that. What's your ability to retrofit those particular assets and get that information? So Sam, if we want to initiate the poll on this, let's go ahead with that.
Yep, we've launched it live, so feel free, ladies and gentlemen, to answer the poll and make your vote. We got some more trickling in here. We'll give it a few more seconds to let everyone make their selection. All right. So of the answers, very few people are not at all, only 3%. 53%, the bulk, are at very little. 29% are almost all. Another small portion of 3% are completely, and 12% have plans for increased instrumentation.
So it'd be very interesting to find out, which particular industries or businesses have the benefit of the almost all or completely, and as well as contrast that with the 53% has very little. So surely that's an important part of adopting the predictive capabilities, and we'll investigate that just a little bit more in greater detail as we go forward.
All right. Give the controls back to you, Dan.
Continue on. Okay. Looking a little bit more at the types of operational data that you might have, one of the things we want to talk about here is what kind of insight that data can actually provide for you. So we have examples of structured information, whether it's SCADA, whether it's historian data from your assets, as well as unstructured information that is retained in a digital format, and applying these predictive models so that there's some of the insight that you can gain to the analysis there, such as which of this potentially 25 different types of data or data sources, which are those best predictor performance of my asset? What are the main factors for failure? And that could be very important in advising in your overall maintenance strategy or parts and supplies or maintenance schedules. Things like insight into what assets are most likely to fail and at what time, or how would you optimize maintenance schedule if you're doing PM at this point. Is there a better way to do that so that you're conducting maintenance only when it's absolutely necessary? If we've done analysis of some of the historical repair procedures via the maintenance logs and such, what were the most effective repair procedures that allowed us to sustain that asset availability and reliability? If we're in a manufacturing mode, what are the variables, whether it's materials, whether it's a particular machine or a particular process, that actually have led to variance in the quality of our manufacturing processes? And if you're in a service organization, how might this data based on usage of assets in the field help you to modify or get a better understanding of what warranty program you should be offering? Taking this idea a little bit more in depth, the idea of data sources and different types that you might have coming from an asset, we have a rich set of modeling algorithms and capabilities, whether it's just looking at historical maintenance records and using that information to advise on the optimum maintenance schedule, whether that's looking at sensor health, that is getting the real-time information, or the historical information from that asset, identifying what your top reasons for the asset failure might be, or what we call an integrated health score, which brings in maintenance and sensor health to give a more holistic sense of that, or feature-based capabilities to help you optimize your maintenance schedules and make recommendations as to the asset health and the optimum maintenance time, or the ability for you to actually do custom algorithms or a combination of all of these in order to meet the specific asset or industry needs of your organization. What we want to emphasize here is that while you might have a large number of data sources coming in from assets, not all of those data sources are relevant in actually doing the predictive capability. What we're trying to show here is that we begin with maybe 25 different sources of data. When we actually do the analysis and apply our algorithms, we might find that a small subset of that really is relevant and important in actually predicting or developing that predictive model. And the message here is that with the power of the analytic capabilities, rather than having to get all of this data and be concerned about the volumes and the different types of data that come in, we really want to give you the ability to focus on what data is really key in developing those predictive models and helping you to understand that asset health and performance going forward. Another aspect of what we do here is the text analytics. This is important. I've mentioned several times that if you do have if you have maintenance records in a digital format, the ability to apply text analytics can provide some insight that you would not necessarily get from just doing the overall analysis of sensor data or historical data that might be in SCADA or in the historian. And here we've got in this particular example looking at the data for a particular shift or a particular asset, and looking at the comments that have been made by those people responsible for the actual maintenance the idea here that although I might see something, a minor change in performance or operational data, it's this level of insight that gives much greater understanding of what was done or what the potential problems were with respect to that asset, what types of repairs might have been done, what additional concerns. And this information can be very important in developing what we call the optimization or how you respond to that particular asset when you see that a particular alert. I just wanted to emphasize here the importance and capabilities for applying textual analysis to operational reports and such that can be very insightful in terms of helping you improve your maintenance practices. In taking that idea one step further, what we do is we give you the capability to actually develop a set of rules. So in this particular screenshot, we're looking at a robotic arm malfunction. What are the potential problems that are part of that, and what are the particular procedures that could be affected in order to resolve that problem? I mentioned earlier that you can have an alert, and that can certainly call your attention to a potential problem, but we want to take that one step further. We want to give you as much insight as possible as to what underlies that particular problem, what are the factors, and based upon that health score and the analysis of that, what should be taken. In this particular example, we're putting together a series of rules so that when we do see a malfunction, it could be one of two things. It could be an issue of low speed, it could be an issue of vibration. If it's low speed, things to look at are stepping motor performance, the capabilities or the current health of that capacitor, and then maybe the actual action taken is to actually go out and do an inspection. In the case of vibration, we're taking that down to the potential problem with the coupling and whether that's an issue of the actual bearings or lubrication. The overall idea here is to take the subject matter expertise that you already have in-house, historical maintenance and repair records, and use the analysis of that to help drive a better understanding of what should be done when you do experience a particular problem with an asset. This is an example of what a dashboard might look like for someone in operations, maintenance, and production. I'm just taking a few screenshots here to give you a sense of what you would see at the desktop and how that would help advise operations, production, and maintenance. In the upper left-hand corner, you see the sense of the asset health score for a particular asset. And I mentioned earlier that we have these different models, such as sensor health, maintenance health, integrated health. And in the green area, that's an indication of good health for that particular asset. What you see here is that depending upon the particular underlying model, that has indicated a specific level of asset health. You could use any one of these or a combination of these in order to advise what you should be doing with respect to that particular asset. Site health score gives you the capability to see a whole category or collection of that similar assets, perhaps 100 machines or robots on the shop floor, or production in throughput in a series of pipelines. The whole idea here is to aggregate that information and give you a high-level view of the asset health at that particular site. On the maintenance schedule, I had mentioned some of our maintenance algorithms that allow you to really optimize the ideal time for the maintenance schedule. So what you can see here is based upon the coloring that forecasted date, next maintenance, PM, the actual scheduled date, and then based upon our underlying asset predictive models, recommendations as to when you might want to actually execute that next maintenance procedure. And the benefit here is, and many times, you could actually extend that period, postpone that particular maintenance based upon the asset health, or if we see some potential asset degradation, actually accelerate or prepend that so that you can accelerate, but that you can actually execute that maintenance procedure earlier. The overall idea is that with the predictive capabilities, you want to address those problems as early as possible in order to minimize maintenance costs and to improve asset availability and reliability. Other examples you see here are analysis of the top failure reasons for a particular asset. This could be very important in terms of helping to strategize on supplies and schedules, so that if you figure that if you see that a particular factor for an asset that this is going to be one of the reasons for failure, how do you address that? How does that advise your overall scheduling of location of spare parts or maintenance schedules? I had mentioned earlier our capabilities to actually do recommendations based upon what we understand is happening with a particular asset and what the historical information has indicated. So there in the left-hand corner, you can see some examples of the recommendations based upon our calculations for that asset health score, such as an urgent inspection, or hey, everything's okay with this sensor health scores, it's within the limits, there's really no problem. When we look at the maintenance health score, and what it recommends is, like, instead of executing maintenance now, consider postponing that as opposed to executing that on a scheduled time. And then the last example is in process and material quality. And the whole idea is in comparison to statistical process control capabilities, using our analytical capabilities to identify those drifts or those changes in process or product quality much earlier than statistical process control. Here's another example, but in far greater detail, to give you a sense of how you might be looking and understanding the asset health. Particular example in this asset shows historical information over a 7-day period. You can see that at the highest level, we've got the asset grouped and under its subcomponents. When we look across the top, we're saying the overall asset health score is 47%, not very good. Probability of failure is 63%. And then as you drill down into some of the details where you see potential problems with a particular pump, where the information that's highlighted in the yellow and orange dots, when we look at that greater detail in the bar chart, we can see that the underlying factors in why that particular asset might be potentially problematic. And going into much greater detail, what are those factors, such as, in this example, booster pump fluid loss, that are actually affecting that? But here you see the ability to drill down to really get a really deep understanding of what is affecting that asset health and how you might respond to that or plan for that and address that. Now we wanted to move on to kind of what I think the core part of this, and how does predictive maintenance and quality complement your Maximo investment? So the first example, and first way to begin this is all of those assets you have defined in Maximo in the database. Those can be imported and used to define the asset definition and predictive maintenance quality, or the description of the asset, the location, all of that data that you have to define those specific assets. The second aspect of this is when you do change the data for the asset information in Maximo Asset Management, we'll automatically pick that up in predictive maintenance and quality. So there's a synchronization as part of that. The benefit here is that rather than having to have to redefine all of these assets within predictive maintenance and quality, you already have them defined in Maximo. We want to import that information and help you to accelerate the implementation and the application of predictive maintenance and quality. The second aspect of that is doing an analysis of the historical repair information, doing a textual analysis and a more detailed analysis. What were the top failure predictors based upon the maintenance and repair records? What was the mean time between failure or time to repair? And using that information to help you get a better understanding of how you might address those particular issues, or how you might optimize the actual maintenance periods. Can you extend those well beyond the current PM, or do you want to accelerate those because you see specific problems that are typically occurring? Mm-hmm. Another example is actually integration with Maximo to initiate a work order.
Hey, excuse me, Dan. I think we lost your presentation there.
You did. Okay, let me back up here. I had a... How about now?
Not yet.
Okay. Let me do one other thing.
It was up and it just kind of disappeared.
Yeah, let me...
There we go.
Good. Okay. All right. This particular example shows how PMQ integrates with Maximo, so that when you do have an alert, a potential problem based upon that particular health score and the rules that you have defined, the ability to automatically initiate a Maximo work order. So we're gathering the asset data that we have established in PMQ that we have originally obtained from Maximo, and we're automatically populating that work order with the information about the asset, the condition of the asset, and potentially even recommendations as to what should actually be done in order to effect that repair on that asset. The overall complementary capabilities, this is one of the key messages here, there really is no overlap in terms of functionality between predictive maintenance and quality and Maximo. These are very complementary. You have the investment in Maximo, you're already capturing repair information, you've established PMs, work schedules, and all the details you have regarding your assets and maintenance scheduling and procedures. What we really want to do and give you the capability with PMQ is to further optimize that so that whether you are in if you are in preventative maintenance or condition-based maintenance, to apply the predictive capabilities so that you can identify potential asset problems or degradation or potential failures much earlier so that you can overall reduce the maintenance costs, increase asset availability, and reliability. So a key message is very complementary capability of these two products. So let's move to a polling question. Sam, if you want to execute that polling question here, your biggest challenges in maintenance practices.
Absolutely. The poll is live and ready for everyone to give us some answers here.
Very interesting to see how these are changing from second to second.
Give it another 15, 20 seconds or so. Let everyone get their answers in.
This is one of the more dynamic polls as I'm watching the numbers change.
All right, looks like we still got a few people trickling in. If give it a few more seconds and let everyone else get an answer in there. Okay. Excuse me. So of the answers, what are your biggest challenges to improving your maintenance practices? 34% answered lack of executive support, 11% lack or outdated CMMS software, 41% budget, 43% current maintenance culture, and 20% other.
It's very interesting to find out what all the categories under other are, but also equally interesting the 43% current maintenance culture. That probably could we could devote a half hour or more to discussing the aspects of the cultural aspects of maintenance in various industries and lines of business. So thank you for your input. Let's continue on. I wanted to give you kind of a scenario for what a maintenance manager might be experiencing based upon all the concepts we've discussed to point. The overall focus for the maintenance manager is schedules, parts availability, technical skills of their organization, the overall efficiency of maintenance schedules and procedures, and then the overall process that they would go through in taking that critical asset, or the critical assets here represented by gears, looking at the structured and unstructured information that we get historically from that asset, and then developing our analytical model specific to that asset. Due to capabilities, what are the most frequent failures? How do we develop the appropriate predictive models that will provide an asset health score, perhaps doing some root cause analysis to help further advise our maintenance practices, or even doing what-if scenarios so that if there's a particular problem, should I address this via the cost? I'm sure you're probably keep getting these pop-ups on my screen.
I'm not seeing any pop-ups.
My screen probably, yeah. Oh, you did? Okay, well, can you still see my screen?
Yeah, yep. Still see you on slide 20 there.
Okay now?
Yeah.
Okay, great.
So.
I just little visual intrusion on my desktop. And we're taking that information, and then I was mentioning the what-if scenarios, and that idea is if I want to address this problem, should be in the fastest time to repair, the most cost-effective means to repair. So it allows you to actually develop these scenarios based upon particular asset health or particular conditions, to develop various scenarios that might be affected when you do have that potential problem with that asset. Now, once that model has been created and the various modeling and scenarios have been put into place, and actually getting that real-time data from that asset, comparing that against our predictive models, and when there's an alert or a problem, the recommendation and the initiation of the work order in Maximo. And at the bottom of the screen, some examples of the potential benefits that can be derived from this. One of the things we do want to communicate is, although we've been focusing on maintenance, we realize that the combination of Maximo and predictive maintenance and quality have benefits for many different parts of the organization. So depending upon your industry or your particular responsibility, put this chart up to give you a sense of, here's the capability, here's the benefit, and here's how they could potentially affect or benefit the various lines of business in your organization.
Dan, I think your slides might not be advancing again.
How about that?
There we go. There's the chart.
Okay. So it's an overall sense of the capabilities and the benefits that can be derived from the combination of Maximo, predictive maintenance, and quality, and how they could benefit the various lines of business. Thought behind this is if you're trying to make the case for moving forward in the adoption of predictive analytics and predictive maintenance, you can take this chart and kind of match that or compare that against your particular organization and business needs, and use that as a way to communicate the benefits internally. But we also wanted to mention that we have an upcoming release of predictive maintenance on cloud. So we've been very successful with predictive maintenance and quality as an on-premise offering over the last 2+ years, but we realize there are many organizations who have moved to a cloud strategy. And so we'll have more details on that. So if you're thinking about a predictive maintenance and these capabilities, like integrate that with your Maximo investment capability, October 20th, this product will be available. So we just want to make sure that we brought that to your attention. Lastly, some additional resources if you're interested in learning more about this. So there's a white paper on predictive culture. It addresses many different aspects of that. It's not really a product paper, but really talks about the capabilities and benefits by applying predictive analytics to your maintenance practices. There's a solution brief that talks about predictive maintenance and quality integrated with Maximo, an analyst report that talks about the quantitative benefits that organizations have achieved or realized by using predictive maintenance capabilities, and some links there to additional product information. We've got one more polling question before we go to Q&A. So Sam, if you want to initiate that, and we might use this also as a jumping off point for some of the questions. Sam?
Absolutely. Poll is live. What would be the biggest advantages to adopting a predictive maintenance strategy for your organization?
This is a good bit of interest to certainly everyone on this call, as well as those of us at IBM, in terms of helping to understand the challenges that these organizations have.
We'll leave it open another 15 seconds or so for everyone to cast a vote here. We've had a pretty good response so far.
Well, the three categories are almost equal there.
Yeah. They were all neck and neck for a good part of it, too.
Yeah.
All right. If anyone else has any other last ones they'd like to cast, we'll leave it open another couple seconds here. Okay. So of the answers, is pretty close among the three. Increased asset availability, lower maintenance costs, and better use of maintenance resources were all pretty much neck and neck. Faster time to repair was close second behind all those, and then a very small percentage We're voting for other.
Okay. Very interesting in terms of the availability as the most important one, but by just a little bit. Certainly it's important for anyone in an asset-intensive organization to make sure that there's the ROI and capability, but also interesting that better use of maintenance resources in terms of, with certainly perhaps limited resources, limited budgets, application of those maintenance skills and resources, and optimizing that key point. So thank you for your response there. We've got one last slide. Hopefully I can get this up and have this shown. There we go. Questions, comments, opinions, and perspectives. Hopefully you're seeing that. So we wanted to open this up to Q&A. And my colleague Ishan Sehgal has joined us. She's offering manager for predictive maintenance quality. And he has a deep amount of information about products, applications, and use cases. So both Ishan and I will attempt to field the questions that you offer.
Absolutely, and thank you, Dan. We will indeed open up for questions. For everyone that joined after the introduction, if you'd like to ask a question, please do so using the chat window located in the lower right-hand corner of your screen. So we've had a few that have come up during the presentation. Dan, I don't know if you had a chance to see some of those. One that came up right from the beginning was, as they were seeing the slides, they wondered, are there examples or references of where predictive maintenance is implemented in real life? They appreciate IBM's visionary thinking, and especially in the maintenance. They, as a business partner, face very conservative customers who want to see references in business cases.
Mm-hmm. Yeah, I mean, we're widely deployed in automotive, in aviation, energy, and utilities. I think those organizations that have the history of strong asset management practices see the benefits of that. And those organizations, it's just, I think one of the questions and concerns earlier in our polling was the ability to have instrumented assets. I think some of those organizations, such as automotive, where they have things like robotics and assets that have been put in place in the recent past that are already instrumented. We've seen a much broader adoption and application in those areas. Ishan, you've probably got a broader perspective than I do, so if you want to comment on that.
Yes, just as you said, Dan. First, can you hear me okay?
Yes.
That across these asset-intensive industries, automotive, electronics, energy and utility, aerospace and defense, chemical and petroleum, these we've had different levels of engagement. A few of them are public. One, Pratt Whitney, in their part of the organization where they're responsible for their own jet engine uptime, and they implemented PMQ to model 3 areas of concern for them. One is in-service shutdowns, others are ground delays. And they were able to use that data to create a dashboard, also to create ability to keep their service uptime at a maximum. Their business model requires them, for their revenue, to be hinged on hours of operation. So they're very interested in using their flight data, their maintenance data, also operator and location data, cycle data on on the status of their engines, their engine types by carrier, by geo. And they saw that depending on the carrier, sometimes a single engine type might have very different performance or uptime characteristics. And they're able to have that on a continuous or real-time basis, ability to look at what's happening, get predictive indications of the health of their engines, and be able to drill down to what and where their attention is needed. Another public reference is Joy Global in the mining area, where they're sort of a connected machine application where their large earth-moving machines or drilling machines are producing a lot of sensor data and event data, and they were looking to use our capabilities to collect that data and do full level of predictive, descriptive, and prescriptive analytics upon.
You know, and that represents both what you mentioned, Pratt & Whitney and Joy Global, kind of a change of the business model, where in the past a customer would buy a particular, whether it's a jet engine or whether it's mining equipment, and they're moving into the model which is, you know what, we're really giving you a capability. That capability is propulsion. That capability is thrust, and we're managing that. Where that capability is the extraction. And the instrumented capabilities give those manufacturers, Pratt and Joy Global, much greater detail into the usage and the performance of those issues in real time than they've ever had before. And back to our slide about the various lines of business that benefit from that. That benefits someone who's actually in engineering and design of those products, someone who's in customer support. So you can see that once you have that information and you're getting that real time from those assets, if you do the analysis and the predictive, that benefits so many different lines of business that have some responsibility for creation, maintenance, and support of that asset.
Excellent.
Another example is in manufacturing, where these assets are, instead of out in the field, they're within a building, and in this case, it's manufacturing assets, PLC-controlled manufacturing assets like robotics or welding machines that are data intensive, that automotive companies are using tools, PMQ in particular, for collecting, analyzing, and taking action on keeping those critical manufacturing assets up.
I'm just looking at some of the other questions that have come in, and if you could see my screen, I have just this little tiny window, and it gives me one line of the question, so I'm scrolling through these. When a predictive maintenance work order is created in Maximo, is there an alert if there's already another work order for that asset? And that's actually one of the benefits in terms of what we decided to do with integration. And if you do have an existing work order for that asset, then we add to that. So rather than having another work order, we really want to make, again, our concept of, or ideas of optimizing those maintenance practices, we add to that work order, and we update that work order, so we're not duplicating it, or we're not creating a second work order for that asset.
Alternatively, instead of just automatically updating a work order or creating a new work order, PMQ can send alerts to Maximo, in this case, so that the operator, the maintenance supervisor, can react to those alerts that are generated from them, from PMQ, and decide how they want to act on them.
Yeah, it's an important point. So that's not automatic, because you do have that subject matter expert. The maintenance supervisor has a much better understanding of the overall scheduling and such. There's a few other questions in here. Text and analytics capability. What's the difference between PMQ text and analysis and Watson text analysis? I think Watson analysis is based upon some of the underlying text capabilities that have come into IBM several years ago. So this is not based on Watson. Watson is far more than textual analytics, but the underlying textual analytics capabilities as been developed over several years. And for our text analytics, in this, it's specifically fine-tuned for extracting those insights from the unstructured information in maintenance reports and warranty reports and repairs. What else? Here's another one, you probably can, as I read through this. How extensive is your predictive asset modeling cookbook? Do you have models for transmission and distribution assets? Are your models configurable based on asset data availability?
Yes and yes. We do actually have energy and utility in the transmission distribution space pre-built as part of PMQ. Some examples are distribution transformers, substation transformers, even some models on cables and telephone poles that were done in a research collaboration with a major energy company. But more importantly, and I think also part of the question is, are these models configurable? And absolutely. Our models, we put a lot of effort in building these models, but similarly, we provide a programming interface and full authoring capability for making new models, tweaking old models, however you want to do that. And not just the models, but same with the BI, as well as the data structure and the connectors. In addition to those specific industry models that I was asked, we have some I would call horizontal or business imperative models around sensor analytics, maintenance analytics that work across different kinds of assets. So out of the box, you can get quite a good start on understanding the health of an asset by mapping the event information into the data schema and running these models such that you get some insight and you can build from there if you need it.
Another question here, it says, hold on. Is IBM PMQ based on Cognos or SPSS? If not, what are the differentiators?
Yes, we do use SPSS as our both authoring environment for statistical predictive models, as well as the runtime environment for those. And similarly for the BI, the reporting analytics, we use Cognos for both the authoring as well as the runtime framework manager part of Cognos for the runtime environment. We have an existing structure so that framework manager model so that as new events come in, those are automatically populated into the pre-built reports. That framework manager model within Cognos is open, so you can add to it, modify it if required.
And there was a question asking essentially, is this a collection of products or is this entirely, an integrated product? And I think you can address that quite well.
It's absolutely an integrated product. While we don't hide in any way what are what we call some of the supporting technologies underneath, PMQ is designed for solving the problem around asset maintenance and product quality and product warranty. This is a purpose-built product solved around collecting data, using our pre-built data schema, our pre-built data integrations. We've spent a lot of energy in creating this runtime environment, so of course beyond building a model, you need to insert it into a continuous process or an operational environment. And that's what PMQ is sweet spot or wheelhouse is. But certainly because these very advanced capabilities are within PMQ, we also make the underlying technologies fully available, like examples that I just mentioned, SPSS and Cognos. But by no means is this a product bundle. It's a specific solution built to solve the problems around maintenance analytics and product warranty, product quality, and is supported under a single license, single pricing, single software support structure.
It's a question that came in earlier. Can predictive maintenance be used without Maximo to report predictive maintenance, or is Maximo mandatory?
Maximo is not mandatory. Of course, it's an IBM product, so we built some specific IBM integrations. But certainly, there's nothing fixed. It doesn't require Maximo, and certainly interoperates with other EAM systems on both maintenance record collection as well as maintenance recommendations output.
Yeah,
Specifically designed to interoperate with a variety of data sources and a variety of systems of engagement.
And if people wanted to integrate PMQ with other systems, one question that came in earlier was building management system or building automation systems. How would that integration be done?
It would be done through our integration bus. We have, again, a programming environment to either use the pre-existing message flows or create new message flows to and from those systems. PMQ precisely sits in between those various systems of record and systems of engagement. We have a pretty advanced message interface bus technology based on IBM Integration Bus, formerly Webster Message Broker, that does just that.
Now, we always get this question, so I definitely want to address that. What is the effort to get PMQ up and running? And we'll begin with a qualified "it depends," but shouldn't you go into much greater detail on that?
Well, depending on the business problem, you're right. You get a different answer. It depends on the scope, the amount of data, whether you're using the pre-built models or the custom models. From an installation perspective, PMQ can be installed within days, as it has an installer that silently installs the components and the appropriate nodes. From a data integration perspective, again, there's pre-built data integration scripts, but that could take a certain amount of time that you would be dependent on how many data sources.
Right, some of the things that we mentioned earlier in this webcast, such as identify your critical assets. What data can you get readily from those assets? Or do you have plans for additional instrumentation to get that data? And it's also important strength of our analytic capabilities and having a library of algorithms and statistical capabilities that we can apply against these data sources automatically to really determine what would be the best predictive model. So rather than having to be concerned about someone who has significant statistical analysis capabilities or someone who's a data scientist, we try to make that as easy as possible by having a lot of algorithms that already have been developed to help accelerate that development of the predictive model and then implementation of that. So I think we are close to the top of the hour. Sam, I don't know if there's anything else, or we can close this out at this point in terms of the time frame.
No, yep, we are hitting about the top of the hour here. So Dan and Sean, thank you very much for your time in answering all those questions. If anyone does have any additional questions, we can work with Dan and make sure we get those answered after the fact. And obviously, if you need to post anything in a forum on the Tivoli user community, we can get any answers for you there as well. But again, Dan, thank you very much for your presentation. I think it went over very well.
Well, thanks, and thanks for everybody for taking the time today to attend this. Much appreciated.
Yep. And on behalf of the Tivoli user community, thank you again, ladies and gentlemen, for attending. As you do exit the webcast, please take a few minutes to fill out your post-event survey and help us improve our future events. We truly appreciate the feedback. But this concludes today's conference. Have a wonderful day.